So this is the fifth part of our scaling of the applications in Node.js. In this video, we will start where we left off in the last video, where we discovered the performance increase obtained by scaling our application across multiple processes. But we have a problem with this approach. Let's see what the problem is. The problem is when processes are serving requests, what if some error comes into picture? Then our server will shut down. But now that we have scaled our application across multiple processes, when one process goes down, rest available processes can still serve the incoming requests. But what if all our processes go down? Then the server will stop serving requests as no process can serve the request because they all are down. This pattern is pretty easy to implement using cluster module. Let's see this in action. Now we will use index.js from previous section and modify it in such a way that it goes down after a random interval of time. We will use setTimeout method to simulate this action. Now inside of our setTimeout method, we will use math.ceil and math.random function to generate random number of seconds between 1 and 3, and also a function which throws an error after that random time intervals that is provided by math.random function. Now you can see on the screen the implementation of the simulation that we have created for forcing the server to go down after a random interval of time. Now we will start the server. As you can see on the screen that all the processes are running on port 3000 controlled by the primary or master process. Our server served the request for some interval of time, but then when the error was thrown, all the server exited one by one as they all faced some error in random intervals. In real life situation, when we have one server to serve the requests, and if that server goes down, our services will be down until we start our server, and in that period of time the incoming requests will not be served. But now we have multiple processes, and if one process goes down, we still have other processes that can serve the incoming requests. But if all the processes go down, we will have to have a way to tackle this setback. Now we will have to deal with the situation in such a way that if we notice a process is terminating due to some error, we will respawn new process in that place. But we know from the previous video that we can only fork a cluster in a primary process, so we will handle this issue when the process is primary. But before we do so, we will go through Node.js documentation to find the solution. So we will go in the cluster module and see what we can do to handle the above scenario. First of all, we will go to the cluster.fork method because we discussed that we can only use cluster.fork in primary process. See, here it is mentioned that this method can only be called from the primary process. Now we will go to the top of the documentation. See, here are some events for workers like disconnect, error, exit, and so on. And if we scroll down, we have some events for our cluster, then we have some methods and properties for our cluster. Now let's check exit event for workers. So here, when process is primary, they are forking a worker and they are listening to exit event. They have some conditions for it. But if you look above, they have mentioned that this is similar to the cluster.onExit event, but specific to this worker or process. So this event is very specific to single worker, but we don't want our application to restart a single worker, but we want it for all workers. So let's have a look at cluster.onExit. See here, cluster is listening to the exit event, but they have also mentioned that if when any of the worker die, the cluster module will emit this exit event. So this is the perfect event for us to use, and if you have a closer look, we have access to the exit code and the worker itself. So using this worker, we can check whether the worker died due to an error or closed intentionally. For that purpose, we have a property in the worker called exited after disconnect that tells if the worker was exited intentionally, this property will be true, and if the worker exited any other way, the property will be false. So we will use this property of the worker and the code parameter of the exit event of the cluster to deal with our scenario. So the condition will be like, if we have a non-zero exit code and if the worker died due to another reason, we will start or fork a new process. So if we use this condition would be like code not equal to 0 and worker dot exited after disconnect is false, we will start a new process by using cluster.fork method. Now we will start the server and load the server with AutoCannon and inspect it. That if our server still shuts down like the previous one that we saw. Now you can see on the screen, if one of the process goes down, it is started again. And our server is serving the request even if we get some error without any downtime. And even though after the stress test is complete, the server is still running.